Okay, today's topic is fundamental trig identities. First fundamental trigonometric identities is quotient identity. Quotient identity. Tangent theta is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta. These two are quotient identities. Next one, Pythagorean identities. There are three equations. Number one, sine squared theta plus cosine squared theta is equal to 1. Next, 1 plus tangent squared theta is equal to secant squared theta. Third one, 1 plus cotangent squared theta is equal to cosecant squared theta. In Precalculus class, you should memorize all of this. They use these three Pythagorean identities a lot. Next one is cofunction identity. Cofunction identity. First cofunction identity is this. Sine pi over 2 minus theta is equal to cosine theta. Or cosine pi over 2 minus theta is equal to sine theta. Cofunction identity means this. When two angles are complementary, sine and cosine values are same. Okay? When sum of these two angles is 90 degree or pi over 2, we call them complementary angles, right? If angles are complementary, sine and cosine are equal. Look at this. In this first equation, angle for sine is pi over 2 minus theta. And angle for cosine is theta. Let's add them. Their sum is negative theta, positive theta cancelled out to 0. So their sum is just pi over 2, right? If sum of two angles is 90 degree or pi over 2, we call them complementary angles. So in that case, sine and cosine are same. Look at this. Sine pi over 3 is equal to cosine x. What is x in radian? I said, if angles are complementary, sine and cosine are same. So x should be pi over 6, right? Because pi over 6, which is 30 degree, plus pi over 3, which is 60 degrees, 90 degrees. So they are complementary, right? What about this? Cosine 40 degrees is equal to sine x degree. What's x? Cosine and sine are equal when their angles are complementary. So x should be 50 degree because 50 plus 40 is 90. Cofunction rules explain about that. If two angles are complementary, sine and cosine are same. And we can use this rule for another functions, like this. Tangent pi over 2 minus theta is equal to cotangent theta. And cotangent pi over 2 minus theta is equal to tangent theta. Same relationship. If angles are complementary, tangent and cotangent are same. For example, tangent pi over 4 is equal to cotangent pi over 4. Pi over 4 are 45 degrees, right? Pi over 4 is 45 degrees. So pi over 4 plus pi over 4 is 90 degrees. They are complementary angles. So tangent and cotangent are equal. Another one. Cosecant pi over 2 minus theta is equal to secant theta. Or secant pi over 2 minus theta is equal to cosecant theta. When angles are complementary, cosecant and secant are equal, and secant and cosecant are equal. Example, secant 20 degree is equal to cosecant what? What's x in degree? X should be 70 degree because 70 plus 20 is 90. They are complementary angles. So secant and cosecant are equal. All right, next. Next fundamental trig identity is even and odd function rule. Even and odd identity. You already learned about even functions and odd functions, right? Even function rule is like this. Even function rule. All the even function equations satisfy this simple equation. F of negative x is equal to f of x. Now all the other functions satisfy this simple equation. F of negative x is equal to negative f of x. We're going to apply these two equations to 6 trigonometric functions. Okay? Out of all 6 trigonometric functions, sine, cosine, tangent, cosecant, secant, cotangent, only 2 functions are even. Cosine x and its reciprocal, secant. These 2 functions are even functions. So they satisfy this rule. And the other 4 functions are all odd functions. Sine and its reciprocal cosecant. Tangent and its reciprocal cotangent. These 4 functions are odd functions, so they satisfy the second equation. Let's make even and odd trig identity. I said cosecant and secant are odd even functions, so cosine and secant are even function. Cosine negative theta should be equal to cosine theta, just like that. And secant negative theta is equal to secant theta. We use them a lot. Next, odd function rule. Sine negative theta is equal to negative sine theta because sine is odd function. Cosecant negative theta is equal to negative cosecant theta. And tangent negative theta is equal to negative tangent theta. Cotangent negative theta is equal to negative cotangent theta. Okay, that's everything. We talked about fundamental trig identities. First one is quotient identity. Second one, Pythagorean identity. Third one, cofunction identity. Last one is even and odd identities. You should memorize all of them completely. We're going to use them a lot to simplifying questions and verifying questions. Next time, we're going to try some questions by using fundamental identities.